There you go. Suzuki, this is for you. Okay, in your Google Drive folder, I put a practice quiz. Where is it? There, right there. Practice quiz for 6.1, 6.2. It's just like the regular quiz, like I said. Copy and paste, put different numbers. That's for Monday, yeah? Okay, today we're going to go over 6.2. Now the real stuff begins. So 6.2. So now we're going to actually learn what an integral is. Okay, so if you have a function, y equal f of x, let's say this is the x-axis, and we want to compute the area between the graph and the x-axis, like this, then this is what we represent it by. It's called an integral. Have you seen your friends in BC using this symbol? No. So what it is like this. F of x dx from A to B. So this is like A to B. So this is how you should think of an integral when you see it. So what we did last night is we found the area of rectangles, right? So it's the same kind of thing. We make a rectangle, except it's infinitesimally thin. It's not like it's 1 or a half. It's really, really thin, infinitesimally thin. So usually in math and science, when you have a change in x, don't we use delta x? You guys seen that before, right? Delta x. That means a change in x. Or in physics, like what do you guys use delta for? Change in kinetic energy is work? Yeah. Or something like that. Anyway, but when it's infinitesimally small, we don't say it's delta x, we say it's dx. So this dx right here represents the width of the rectangle, but it's really, really thin, infinitesimally thin. And then what about the height? So this is the base, this is the height, because doesn't f of x tell you the y-coordinate, right? And since this rectangle is so infinitesimally thin, it doesn't matter if you use the left endpoint, the right endpoint, the midpoint, it doesn't matter. F of x is the y-coordinate of the point. So this is like height, that's the base. So when you multiply length times width, that tells you the area of this infinitesimally thin piece of rectangle. So if we want to get the exact area, we have to add up all of these rectangles. That's what this does. You see the integral kind of looks like an S? That's because it stands for sum. We're going to sum up all of these rectangles that are infinitesimally thin from A to B. So just think about this. You're just adding up these rectangles from A to B. And like I told you, if you want to get the exact area, you have to add up an infinite number of rectangles. So that's exactly what we're doing because it's infinitesimally thin. Last night you added up, what, 4, 6 rectangles? That's just an approximation. But if you add up an infinite number of rectangles, then you get the exact area. So this integral represents the area between this graph and the x-axis from A to B. So what you're going to do tonight is you're going to compute these definite integrals. That's the title of this chapter. It's called definite integral. A definite integral is an integral that goes from A to B. You're computing an area. Okay, so let's start off very easy. Cool question.
If we can get the exact area, why would we bother to do like a rough estimate?
Because sometimes you cannot get the exact area. So you have a computer or calculator, give it to as many decimal place accuracy as you need. Because there are some functions that cannot be integrated, as you will find out later. But right now we're still in the infancy stage here. Okay, so tonight you're just going to see a whole bunch of integrals. Okay, let's start off easy. Integral of 3 dx from 1 to 5. So what you have to do is you have to be able to compute this without a calculator. Well, do we know what the graph of y equal 3 looks like? Yeah, it's just a horizontal line. 1, 2, 3. 3 units above the origin, like this, right? And we want to compute the area between this graph and the x-axis from 1 to 5. So here's 1, 2, 3, 4, 5. So from 1 to 5, we want to compute this area right there. Can we do it? Yes, it's a rectangle. So what's the base? If this is 1 and 5, what is this? 4, right? Right minus left. Top minus bottom. I'll just go like this. This is 4. And then what is the height?
3.
This is 3. So therefore, answer is 12. So an integral simply tells you the area between the graph and the x-axis from x1 to x2. Which means you have to be able to draw graphs. Uh-oh. Okay, horizontal line, easy. Let's do some regular lines here. How about the integral of x dx from 0 to 4? Okay, do we know what the graph of y equal x looks like? I hope so. So y equal x. From 0 to 4. 1, 2, 3, 4. So the integral from 0 to 4 computes the area between the graph and the x-axis. Can we figure out that area? Yes, it's a triangle. These are simple geometric shapes. So we simply have to go 1/2 base times height. So 1/2 base times height, because, and you're going to see a lot of triangles on tonight's homework. Okay, what's the base? How far is it from 0 to 4? 4. And what's the height?
4.
How do I know it's 4?
Plug it in.
Yeah, you can plug it in, like, right? If this is the graph of the equation y equal x, if the x coordinate is 4, you plug it in and you get the y coordinate is 4. Or you can think, well, isn't the slope of this line 1? So the rise over run should be 1. So if this is 4, that's got to be 4, right? I mean, you can figure it out in lots of different ways. Final answer?
8.
8. Okay, you guys think you're good, yeah? Well, let's see. What is the integral from -2 to 0 of x dx? Okay, well, it's the same graph, y equal x, except we're going from -2 to 0. So draw in this. Now we need to compute the area of this triangle. That's easy, Mr. Park. It's 1/2 base times height. What's the base? How far is it from -2 to 0? 2. What's the height? 2. So 1/2, 2 times 2, is that the answer? Why not? There. How do you know? Okay, but there you go. That's exactly right. The answer is not, what does this say? 2? The answer is not 2. It's -2. Now, why would the answer come out negative? Because the graph is below the x-axis. Oh, so whenever the graph goes below the x-axis, then the integral has a negative value. Now, this is very important to know. Area cannot be negative. There is no such thing as negative area. However, the value of an integral can be negative. You see the difference? Area cannot be negative, but the value of an integral can be negative if the graph goes below the x-axis. So if that's the case, what do you think the integral from -2 to 4 will be of x dx? Well, if this one was 8 and this one was -2, I'm not saying the area is -2, the integral is -2, so what do you think the answer should be? It's right, 6. Because this is below the x-axis, it counts negative. So everybody understand, if the graph goes below the x-axis, it counts negative now. Okay, are we ready to graduate to more complicated graphs? Well, it doesn't matter because we're doing it. Integral. Integral, let me think of a more interesting graph. How about x over 2 plus 1? No, let's go x over 2 minus 1 dx from 0 to 8. Okay? So, what's the best way to draw this graph? It's a line, right? The slope is 1/2, the y-intercept is -1. How do you guys want to graph it? 1, 2, 3, 4, 5, 6, 7, 8. Okay, the y-intercept is -1. Well, how about plug in 8 then, right? If you plug in 8 here, what do you get? 8 over 2
3.
is 4 minus 1, you get 3. 1, 2, 3, 8, 3. So the graph looks like this, right? Shoo. So from 0 to 8, we have to compute this area and then that area. But again, when it's below the x-axis, it counts negative. So what's the area of this triangle? 1/2 base times height. 1/2 2 times 1. Here, I'll even write it out. 1/2 2 times 1, but it counts negative because it's below the x-axis. What is the area of this triangle? 1/2 base times height. What is the base? 6. And what's the height? 3. Right? Because the slope is 1/2, right? Rise over run got to be 1 to 2 ratio. Okay, so if you write that down on your paper, you get everything except 1 point. Again, you got to simplify until we get to the fourth part. So what is this? -1 plus 9. Final answer? 8. Whew. So the key is you have to be able to draw a pretty accurate graph. Okay, so I'm pretty sure you guys can handle lines. Now, what about some other kind of things? Like, for example, how about absolute value x minus 1 minus 1, no, x plus 1 minus 1 dx from -2 to 4. How do I draw this graph? Well, what's the base graph?
A V.
Absolute value of x, which is the v, but then you gotta shift it 1 to the left and 1 to the down. So 1 to the left and 1 to the down, so it's gonna look like this. And then, okay, and we wanna go from -2 to 4, so 1, 2, 3, 4. So here's -2, here's 4. So we need to compute this area, which is going to count negative, and then we need to compute that area, which is going to count positive. So what's the area of this? Let's just do it in our head. 1/2 base times height. This is 2, this is 1. 1/2, 2 times 1. 1, okay, this area is 1. I'll just put 1 there. Okay, what is the area of this? 1/2, 4 times 4. 8. So what's the answer? 7. How come? Because this one counts negative, it's below the x-axis. Okay, so we can handle that kind of absolute value graphs, right? Okay, here's another one that's going to come up a lot on tonight's homework, and that's why we reviewed it when we did the pre-calculus review. How about the integral from -1 to 1 of the square root of 1 minus x squared dx? Who remembers that graph? Remember I told you it's gonna be important in calculus? Well, now it is. Come on, somebody gotta remember. It rhymes with hemihercle. It's a semicircle of radius 1. The square root of that number is the radius. So the graph is a semicircle of radius 1. So 1, 1, 1. It looks like this. So we want the integral from -1 to 1. So it's going to be the area between the graph and the x-axis, like that. Can I figure out that area? Yes, it's half a circle, right? So what is the area of a full circle? Pi r squared, right? And this is just half of it.
There.
And what's the radius? 1. So final answer? Pi over 2. Okay, but on tonight's homework, and I like to put this on my quizzes, let's put a variation of that circle. How about the integral from 0 to 3 of 3 minus the square root of 9 minus x squared dx? Okay, well, look, What is this graph right here?
Wait, isn't that just a square or semicircle radius?
Okay, well, let's just take it piece by piece. What is this graph? We just talked about it. It's a semicircle of radius 3. Okay? So let's see. The key is you got to, if you don't draw the graph correctly, you're not going to get anything. 1, 2, 3. 1, 2, 3. 1, 2, 3. So the graph looks like this, right? What does that minus sign do? It reflects it over the x-axis. So now it looks like this. And then what does the plus 3 do? It shifts it up 3. So this graph here has to move up 3. So doesn't the graph look like this then? Yeah. Okay, so we want the integral, so that's the first part. You got to be able to draw this graph. And then we want the integral from 0 to 3. That means here's 0, here's 3. We want the area between the graph and the x-axis. Right there. How can I figure out this area? Use geometry. Yeah, but I don't know that shape, Mr. Park. Well, you know this one. Like if you were to draw this in right here, what is this area here? I'll do a stripe line like that. Well, what's the area of this whole thing? Isn't that a square? Right? And then what is this? Isn't that 1/4 of a circle? Because look, if you make the whole circle, it looks like that, right? So how can I find the area of the shaded region? The square minus the 1/4 of a circle, right? Basic geometry. Okay, so the area of the square is 3 by 3, so that's 9. Minus 1/4 of a circle. And the area of a circle is pi times the radius squared. And what's the radius of the circle? 3. There you go, that's your answer. AP exam, that's full credit, but we need to simplify. 9 minus 9 pi over 4. Boom. So the key is, you gotta be able to draw the graph. So most of the problems on tonight's homework will be lines, but you're gonna get several semicircles in there. And then you gotta do stuff to it. Now, I'm not sure how much you learned in your other classes. Maybe I should just do it as a bonus. Because I think I mentioned it on one of the, well, let's just do it. Integral. You know what, I'm not gonna, okay, I will. It's better if you know. Okay, what is this graph? Is that a semicircle?
No.
No, because it doesn't have the square root. This is a parabola. What are the x-intercepts of this parabola?
2 and negative 2.
And the y-intercept is 4, right? Parabola opens down like this. So the integral from negative 2 to 2 is the area between the graph and the x-axis. Right here. Any idea how to compute this area? Did anybody learn a formula? Archimedes formula in pre-calculus? No, okay, well, see, if it's not a special shape that we know, how do we compute this area, Mr. Park? Like, what if you have like a sine curve or something like that? Well, that's why we have to get to 6.4, because in 6.4, we're going to learn the fundamental theorem of calculus, which is, it's a theorem that allows us to compute the area under pretty much any graph. But we got to wait till we get there. So right now, the only way we can compute this area is by using your calculator. So in your book says use NINT. Now what NINT means is numeric integrator. That basically means your graphing calculator. Now do you know your calculator can compute integrals?
No.
Okay, so I will show you. So we want to compute this one here. So I have it on the screen. So you gotta be able to punch in integrals on your calculator and be able to compute it quickly.
What is that?
Man, Mr. Park, how do you draw like such perfect curves? Your
Uh,
circle is like perfect.
37 years of experience. I don't think they're perfect though. Okay, anyway, you see the template button right here, the one above the cosine? See the one above the cosine? The template button, press that.
I can't see.
And do you see the integral right there, this one right here? So from the top left, go to 4 to the right and 1 down. Or is that 3 to the right, whatever. This one here, see the integral?
Uh-huh.
Click that. And then all you gotta do is fill in the boxes that they have there. Here, can I make this bigger? A little bit bigger. Okay, so what number should I put in that box there? What does it say? No, -2. So,
Oh, yeah.
-2. You cannot put -2 now, you gotta put -2. You gotta use this plus minus button. And then you go, what about the upper box?
2.
2. And then this box here, you have to punch in the function.
Whatever.
4 minus x squared. Do I need a parentheses just to be safe? 4 minus, where's the x button? Oh, x squared. And then what do I put in this?
X.
X. You always have to have a dx because that's like the width of the rectangle. And then you got a right arrow to get out of it now. Press the enter button, boom, and there you go.
Is that the exact answer?
Well, your calculator can do it correct to like 5 or 6 decimal places. Well, in the old calculator was 5, and I'm assuming this one is better. So what your calculator does, I think it's programmed to just add up like 1 billion rectangles, but it can do it really quickly. And that should be good enough. Anyway, you can probably guess that the real answer should be 10 2/3, right?
Yeah.
10 2/3. So, when we get to 6.4, we'll be able to do it. However, Archimedes, back in the day of the ancient Greeks, he figured out a formula. Now, this only works for parabolas now. So do not think that any U-shaped thing is a parabola. A parabola has to have a certain equation like this. So do not use this on any U-shaped thing. It has to be a parabola. Anyway, Archimedes said, he said the area under a parabolic arch is 2/3 base times height. No teacher ever told you that before?
Maybe. I remember though.
Well, think about it. What is 1/2 base times height? Wouldn't that be the area of a triangle?
Yes.
So he went, oh, this could be a little bit more, so 2/3 base times height. Only one person got my joke there. No, he spent years trying to figure this out. Anyway, so if we apply it to our problem, 2/3 base times height. What is the base? How far is it from
4.
-2 to 2?
4.
4. What's the height?
4.
4. So what is that? 32/3. Is that the same thing as 10 2/3? Yeah. Why would I teach you something that doesn't work, right? But again, if you are going to use this, you gotta make sure it's a parabola. Well, actually, now that I told you this, I can put it on the quiz, yeah?
No.
Who's?
You said that.
Oh, since we have our calculator, okay, let's do this now. So right now, we're kind of limited to the kinds of integrals we can do. It has to be simple geometric shapes. That's why some of the problems, you're required to use the calculator, otherwise you can't compute it. Like for example, what about 1 arch of the sine curve, y equals sine x? Use your calculator to compute this area. Well, what integral represents this area? The integral of f of x dx, and then from 0 to, okay, very good, 5. Okay, punch that in on your calculator, and hopefully you're in radian mode now. Anytime you do trigonometry, you have to be in radian mode.
Anyone get the answer
Hmm?
yet?
Come on, don't you guys have it on your iPad, the app? This app right there? No, but I'm gonna press my finger on the thing. Really? Don't make me walk to my desk and punch it in. Actually, I know the answer already.
What is it?
2, 2.
2. Isn't it kind of amazing?
Wait,
The area under one arch of the sine curve is exactly 2 square units. It's exact. Well, we're gonna learn how to do this when we get to 6.4. Okay, I'm just warning you now. In order to use the theorem in 6.4, you have to be able to do the derivative backwards. So if you don't know your derivatives well, you're gonna struggle. So you better start memorizing those derivatives. That's the key to computing integrals. You have to do the reverse of the derivative. Okay, so if that's the case then, what would be the integral of sine x dx from 0 to 3 pi over 2 then? So here's 2 pi. So 3 pi over 2 would be here.
1,
So what would the answer be?
1.
1. How come? Because if this is 2, then isn't that half of an arc? So that's 1, but that counts negative because it's below the x-axis. That's the kind of thinking you have to do. So now you can use your calculator. So you can so when you do your homework, whenever it says use MINT, numeric integrator, that means take out your graphic calculator, because everybody has different kinds of calculators. So this is just the book's terminology for whichever graphic calculator you have. Numeric integrator. What about something weird? Let's do something weird. Somebody give me a funky equation. Okay. That's not that funky. I was thinking like e to the something.
X squared minus 1 over x cubed.
Oh, okay, I'll just make up something. E, y equals e, x, e to the negative x. Okay. As x approaches infinity, it's going to go to 0. So it looks like this. That's what the graph looks like. I think you guys can graph it on your calculator. Okay, let's go from 0 to, what is this? 4, say. Compute this area on your calculator. You're going to have to do this on the quiz now. There's going to be one calculator where you get to use your calculator. You got to be able to punch it in. So, integral from 0 to 4 of f of x dx. Now, actually, maybe after Christmas vacation, we'll learn how to actually compute this without the calculator. But there's a whole bunch of things we got to learn. Can you imagine? How do you find the reverse derivative of this? It's called the antiderivative. What do I have to take the derivative of to get this? So what you got to do, doesn't that kind of look like something from the product rule?
Yeah.
So what you have to be able to do is you got to reverse the product rule. Mr. Park, I don't even know the regular product rule. Anyway, punch that in on your calculator. Come on, you guys got that. It's like at your fingertips already. I wish look, what about smart, look, on my phone, I cannot do anything except add, subtract, multiply, and divide. I bet you on your phone you can do this, right?
Probably.
Do you have this app on your phone? Or an app like it?
Later.
I don't know, you want the decimal, you want the fraction?
I want the decimal.
0.9084.
Okay, just 3 places, that's all we need for AP exam. Everybody got that? Don't nod your head when you guys didn't even do it. Strike 1. So, I almost forgot. Okay, so there's going to be a whole set of problems. This is the last problem on your homework tonight. I almost forgot to do it. And you really have to know how to draw graphs for this. Yes, and it'll be on the quiz. So they tell you, they just give this to you. The integral from 0 to 1 of x cubed dx is equal to 1/4. Okay, this is actually true. So what does this mean? What does the graph of y equal x cubed look like? Doesn't it look like this?
Yeah.
Right? So from -1 to 1, the area between the graph and the x-axis, this area right there, is 1/4. So based on this information, okay, compute, okay, let's do 2 examples. Integral, I gotta think. let's just go 0 to 1. I might have to revise that because I'm not thinking clearly right now. Okay, can we draw this graph? The key is you have to be able to draw this graph. Well, here's the base graph, y equal x cubed. What does that do to the graph?
With it,
Reflects it over the x,
Up one.
and then up 1. Okay, so here we go. You gotta be able to graph, so 1. Okay, so when you draw this graph, to me the easiest way is go 0, 0, 1, 1, negative 1, 1. It goes like this. Dun, 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 dun. And you have to get the concavity correct. Because if you just draw it kind of straight, you see how like this is like, if you draw a straight line here, that would be a half. So that's why you gotta make the concavity correct, otherwise you're not gonna be able to see it. Okay, reflect it over the x-axis. So now it looks like this. And then I have to shift it up 1. So take this graph and it goes up 1. So now you're gonna have this, this, and this. So the graph looks like this. Okay, so the integral from 0 to 1 will tell you the area between the graph and the x-axis from 0 to 1. So here's 1 right here, right? So the area between the graph and the x-axis would be the area right there. What is it? So what's the answer? It's 3/4. How come? Because if you make a square, isn't that one 1/4? Isn't that the same thing as this? See how the concavity goes? So therefore, the area of the shaded region is the square with 1 by 1 square, which is 1, minus that. 1 minus 1/4 is 3/4. That's why if you don't get the concavity right, it's kind of difficult to tell. So you're going to have a whole bunch of problems like that. So you have to be able to graph. In fact, there's one difficult one, but I'm going to see if you guys can do it. In fact, what the heck? Let's just do it now. I don't remember exactly what it was. I think it was like this. You have to be able to graph this. What was it? X cubed minus 1. No. 1 minus x cubed, like that. Maybe it was this? It could be. And then you put absolute value only on the x. Or something like that. I don't know. I don't think it's exactly that. So we know how to graph this, right? Okay, so let's graph, okay, here. We just did it, it's right here. So here's 1, and we go 1, and then 1. It looks like this. What happens when you put the absolute value only on the x? Okay. Erase everything to the left of the y-axis. Keep and reflect the remaining portion about the y-axis. So this, and then this. In other words, you have to know how to do this. So whenever you graph something like this, do this and go, oh, I know how to graph that, so graph that first. And then when you put the absolute value only on the x, erase everything to the left of the y-axis. Keep and reflect the remaining portion about the y. You're supposed to do that in pre-calculus. So what if I gave you the integral of this dx from -1 to 1? What would be the answer? Here's -1, 1. What is the area between the graph and the x-axis? Okay, let me ask you this. Can I use Archimedes' formula? Can I go 2/3 base times height? No, this is not a parabola. How can you tell? Because there's a cube on it. If it was a parabola, then you can. Remember, you can only use that formula for parabolas. So no, you cannot use it. Well, what did we just learn? Look, make the square. We know this area is 1/4 and that area is 1/4. So therefore, this one is 3/4 and this one is 3/4. So the answer is 3/2. So you have to be able to graph.
Should we just know that that's 1/4?
Well, for this graph, I'm going to give you the same thing. I'm just going to, like, instead of a plus, I'll put a minus or something. Because look, If you make a 1 by 1 square, if that's 1/4, then this bigger one there is gonna be 3/4, right? So that's what you're relying on. See, the small one is 1/4, the bigger one is 3/4. But you gotta be able to draw the graph, you gotta see if it's above or below the x-axis and things like that. All right, now I covered everything. So what are we, oh, so tomorrow we're gonna learn properties of integrals. That's kind of easy. And then finally next week, we're gonna finally learn how to compute an integral without a calculator. And again, you gotta, maybe we should practice little by little every day. So, in other words, if you know the derivative, you have to be able to come up with the original function. We call that the antiderivative. Okay, so I think we did one yesterday, yeah?
Yeah.
Okay, or the day, whatever it was. Okay, what about x to the 5th? What would be the antiderivative of that? Like, what do I have to take the derivative of to get this?
1, 6.
Because remember, how do derivatives work? You put the power in the front and reduce it by 1, right? So if you go the opposite direction, you gotta increase the power by 1. So shouldn't it be x to the 6th?
No, it's 1.
But then, when I drop the 6 to the front, I have to cancel it out with something. 1/6, right? You put the 6 in the front, they cancel out, and you get this, right? But then you have to put plus a constant, right? Because the derivative of a number is 0. How do you know that number is 0? Couldn't it be plus 5 or minus 7? So you have to put what we call a constant there, plus c. Okay, so this is like the easy kind. What about something like this? What would be the antiderivative of that? Well, change it to x to a power.
Negative.
Okay, good. So remember how you take derivatives?
Yeah.
So when you go backwards, the power gotta go up 1. So it's gonna be x to the half. What do I have to put in the front to cancel out that half?
2.
A 2 and then plus c. Hey, Mr. Park, as long as I can add 1, you can do it. Yeah. Until we get to the trig and other derivatives. Okay, you guys think you're good, yeah?
No, no.
Okay, what about that? What do I have to take the derivative of to get this?
Secant for.
No,
No, secant x.
just secant x plus a constant.
No, secant something else.
Also, yeah, you gotta know your antiderivatives, that's right. Okay, here's one that you guys probably forgot. Okay, so this is the same thing as x to the what power?
Negative 1.
Oh, so easy, Mr. Park. Make the power 1 bigger.
1.
No, 1 bigger.
0.
And then put the reciprocal over there plus c.
No.
No, 1 over 0 is undefined. You can't do that. Come on, somebody.
ln(x).
Oh, there you go. Natural log x plus c.
Whoops.
Have we forgotten the derivative of natural log x is 1 over x?
No.
Apparently we forgot. Anyway, this is just leading up to 6.4. See, if you cannot go backwards, then you cannot do anything. But before you can go backwards, you gotta go forward. Maybe we're gonna need an antiderivative speed quiz.
No, we didn't even have a regular derivative speak.
Okay, maybe we'll have that question.
Yes, I'm going back. How did you get the 3 over 2? Sorry, I'm not even asking you anything about that.
Oh, because
Yeah.
3/4 plus 3/4 is 3 over 2, right?
Oh, so wait, what's the question? Like, what were we?
Fine. Remember, an integral tells you the area between the graph and the x-axis.
Oh,
Yeah, so it's that shaded region. It's always between the graph and the x-axis. But we just drew the squares in so that we can figure it out, though. Yeah. Okay, we are done. Suzuki,
Mr. Park.
we're making this video just for you.
There's no.
Okay, wait. Let me turn this off.